Hi, what's up everybody? In this video, we are going to talk about nodal analysis. What do we mean by nodal analysis and how can we use nodal analysis to solve circuit or problems in circuit? Now, with the definition I have here, we say nodal analysis, node voltage analysis, or the branch current method. You can call it nodal analysis, node voltage analysis, or the branch current method. It is a method of determining the voltage between nodes in an electrical circuit in terms of branch current. As you can see, with the diagram I have below here, you can see this one is 1, this one is 2, and this one is 3. So this is what we mean by nodes. This is node 1, this is node 2, and this is node 3. Let's assume these lines that contains resistors, they are wires. Okay, now this line also, they are wire. Any line that we see here is let's assume it's wired. We connect this line, we connected it together with this one. So this one is coming here, it joins here. This joint is called node. And another one goes this way, and another one comes this way. Then this one joined here, and this is a joint, and this joint is called node. Okay, then we have another one here, and we have another one here. So this one joined here, so we call this one node also. And we have another one here, we have another one here, and this one is coming this way, so they join here. This is another node. Okay, so we will do a lot of exercises on nodal analysis so that you will be able to understand and able to tackle any circuit being given to you. Maybe you are preparing for exam or tests. Okay, now this one, we can call this one V1. That is, you can also name it A, B, C, D. Now listen attentively. I want you to take your book and your pen so we can work this together, so you'll be able to understand how we got it. Okay, pay more attention please. You know, this one is 1, this one is 2, and this one is 3. So we can say this one is V1. That is, we are going to calculate the voltage that drops here. Okay, and V2. You can name it anything. You can name it A, B, C, D, like I said earlier. And this one is V3. Okay, this one is V3. And you are looking at this. We can say this one is 4. But you see, all these lines, all these wires in this circuit are being connected to this place. So we call this one reference node. Okay, what did I call it? I say reference node. You can say ref node. Okay, now this reference node is also known as 0 volt because it's connected to the ground. Okay, this reference node is 0 volt. Keep that in mind. And because it's connected to the ground, all this one comes this way, so it's connected to the ground. So we call it reference node, and the reference node is 0 volt. Have that in mind. Okay, so don't forget, we are going to calculate the voltage that drops here, the voltage that drops here, the voltage that drops here. Okay, now let's solve this circuit so you'll be able to understand it. We are going to call this one we can say this one is introduction, and we are going to solve this circuit, and more circuits will be solved. Okay, please pay more attention. Don't let anybody disturb you. For this circuit that we have here, let's try to solve it. Let's redraw the circuit. Okay, let's redraw the circuit that we have here. let's say the question says the question says find the 3 node voltages in the following network. Okay, let's write that down. Let's call this one exercise 1. Exercise 1. So find the 3 node voltages in the following circuit or network. You can also say circuit, it's the same thing. Okay, now let's redraw the circuit. I mean the circuit that we have here earlier. This circuit, we are going to redraw it so we can solve it. Okay, we have so this one is a resistor, and also we have another one here. This is also a resistor. Now we have a current source. This one is current source is 10 ampere. This one is 3 ohms, this one is 2 ohms, this one is 4 ohms, this one is 6 ohms, and this one is 4ix. Okay, 4ix is the same thing as what we have here. Now let's go and put this v1, v2, v3. In my own case, I will be using v1, v2, v3. It can be VA, VB, VC, V1, V2, V3, and this one is connected to the ground. We call it what? Reference node, ref node, 0 volts. Okay, that is 0 volts. Let's solve this. Before we move on to solution, we are dealing with current. This circuit is parallel circuit, series parallel circuit. So this V1 here, we have a current source here. This current source is entering this place and it will be leaving. So like this, let's say this one is I2. Let's call it I2. You can call it anything, but me, I will call it I2. Now another one is flowing here. Let's say this one is I1 that is flowing here. Then another one is flowing. We have 4ix here already, and this place we can call this one I4. No, I3. I will call this one I3. We have 4ix here. Now the current flowing here will be, this one will be Ix. Don't forget Ix. Please pay more attention so it won't be lost. The current flowing here, we already have current source here, 10 ampere. Then the one flowing out here is I2, and this one is I1. This one is 4ix already, and this one is I3, and this one is Ix. Okay, now let's jump into solution straight. Now before we can solve this, we have to apply some laws. Okay, we call this one KCL. You familiar with KCL? current law or Kirchhoff current law. Now, let's say we apply KCL. Applying KCL at node 1, okay? Node 1. You know this one is 1, this one is 2, 3. We call it V1, V2 because we are going to determine the voltage that drops here, the voltage that drops here, and the voltage that drops here. So let's apply KCL at node 1. Now pay more attention before we can apply the KCL to this side. Remember that in KCL, that is Kirchhoff current law, it says that what? The algebraic sum of current entering a node is equal to the algebraic sum of current leaving the node. Okay, the algebraic sum of current entering a node is equal to the algebraic sum of current leaving the node. You know that. Then another definition for KCL, we say the algebraic sum of current entering a node is equal to what? 0. Please put that in mind. Okay, KCL, the algebraic sum of current entering a node is equal to 0. Here now, let's use KCL. Please pay more attention. We are going to, this one is node 1, node 2, node 3. We are working on node 1. So that means we are going to disconnect all this one and this one. So when we disconnect this one and this one, it will remain this, and this. Do you get that? It will remain this, and this. So it will remain this I1, I2, and this 10 ampere. Okay. Now, let's say this 10 ampere is already fixed there. You can give it anything, so you'll be able to understand it. This 10 ampere is entering. The arrow is up. Is entering the node. We can say plus. That one is plus 10 ampere. That is, it can be, you can name it I4, anything, IV or anything, but me, I will use it straight like that because we've gotten the current there already. That is current source. So 10, and let's look at I2. I2, is it entering or leaving? Look at the arrow. Is it entering or leaving? It's leaving now. Yeah, it's leaving. That will be minus I2. Okay, now let's look at another one. I1, is it entering or leaving? It's leaving. It's also minus. When it's leaving is minus, when it's entering is plus. I1 equal to 0. That is first definition. I'll say the algebraic sum of current entering a node is equal to 0. And now let's collect like terms. That is, we are going to carry all this one to this side. Okay, now 10 equal to, when this one comes this way, it will be plus I1 plus I2. We carry all this one to this side, so making plus. You get that? Now, as we have it like this, I call something flip. I can flip it anyhow, so it's still the same thing. I can write it like this: I1 plus I2 equal to 10. Okay, equal to 10. It's still the same thing. I just flip it like this. It's still the same thing. Now, what are we going to do now? We said this one is I1 plus I2 equal to 10. Wow. It's very simple. I1, that I1, before we can get current, remember, let's apply Ohm's law. I just want to apply this Ohm's law here. So the rest you know Ohm's law. Ohm's law mathematically, we say I equal to V over R. That is V against R, okay? V ratio R and now V over R. So, and this I, we have I1 here, we have I2. Please pay more attention. We can use this one to decode everything, okay? So, since we've gotten I equal to V over R, this I1, where is I1? This is our I1. You know, I1 is between two nodes, that is this V1 and look at it, V2 is connected to V1 and V3. So here comes this way V3. Now this is what we are going to do for that. Since we said I equal to V over R, so what are we going to do? We will now say V, please pay more attention, V1 minus V what? V3, good. V3 over the resistor between the nodes, that is this one. The resistor here is 2 ohms, okay? 2 ohms, that is divided by 2. It doesn't matter you put the ohms, just write it like this, over 2. Now look at this one. Look, come here. You say I1 plus I2. That is, we've already gotten the I1. That is, the I1 is V1 minus V3 over 2. Let's work for the I2. Where is I2? Look at the circuit. This is I2. Okay, this is I2. You know, this I2 it starts from this V1 to what? V2, and between it we have 3 ohms. 3 ohms. Don't forget the sign. The sign here is what? Plus. You will now put plus. Okay, plus, you know it is I2. So where is the I2? I2 starts from here to here. So it will be V1 minus what? V2. V1 minus V2 over what? What is the resistor? Remember the Ohm's law. What is the resistor? The resistor is 3 ohms. 3 ohms. Okay. So now we now have V1 minus V3 over 2 plus V1 minus V2 over 3 equal to what? Don't forget, is equal to what here? 10. Thank you. 10 is equal to 10. Now, can we leave the equation like this? No. We cannot leave the equation like this. What are we going to do? We are going to find the LCM of these 2 and 3. What comes to your mind? You know that 6 comes to your mind. Good. So the LCM of 2 and 3 is 6. So we now use the LCM of 2 and 3 to multiply the both sides using the LCM of 2 and 3 to multiply the both sides. Don't forget that you can say multiply both sides by the LCM of 2 and 3. I think that one is straightforward. Using the LCM of 2 and 3 to multiply the both sides, we are still saying the same thing. Now, what are we going to do? How are we going to do that? By using the LCM of 2 and 3 to multiply the both sides. You already know that the LCM of 2 and 3 is 6, because 2 can go in 6, 3 can go in 6. Good. So you will now do it like this. You will now put everything in bracket. Let's rewrite it. 6, look at it too, into bracket V1 minus V3 over 2 plus V1 minus V2 over what? 3. Close the bracket, equal to, put that 10 also in bracket, 10 multiply by what? 6. You can write it like this, you can write it in another way, but write it in like this is very simple. And also we have many ways to write it, so for better understanding. Now you already know that this 6 is working for this term and this term, okay, and that 6 also we put it here. So we will have been put all this one inside bracket, okay, but let's use it like this. You know, any whole number, any number that stands alone is whole number. Any number that stands alone is whole number, and whole number is always over what? Over 1. This 6 is over 1 because 6 divided by 1 is also 6, and this 6 will only work for the numerator, not the denominator. You can use this 6 to multiply only the numerators. This is the numerator, and this one is denominator. But what are we going to do if we start to use 6 to multiply the numerators? That is 6 times v1, 6v1 minus 6v3 plus 6v1 minus 6v2. To be time consuming. So what are we going to do? Let's solve this term first. 2 in 6, that is 6 divided by 2 is what? 3. Thank you. 3. It will be 3 v1 minus v3 over 2. You get that? Now let's come here again. 6 divided by 3 is what? 2. Thank you. Don't forget the sign, plus 2 into bracket v1 minus v2 over what? 3 equal to 10 times 6 is what? 60. Thank you. 60. Now let's start. We don't supposed to write these 2 here. Okay, let's cancel it because we've using it already. Sorry for that. Let's cancel it. Let me rewrite it. So 3 v1 minus v3 plus 2 v1 minus v2 equal to 60. So it should be like this, not like this. Okay, 3 times v1, 3v1 minus 3v3, 3 times v3, okay, plus 2 times v1, 2v1, 2 times v2, 2, is it plus or minus? Minus 2v2 equal to 60. Now look at this equation like this. 3v1 minus 3v3 plus 2v1 minus 2v2. So what are you going to do? Let's collect like terms. Collect like terms. Okay. Now, when we are collecting the like terms, we have 3v1 here and 2v1 here. It's common. 3v1 plus 2v1 minus 2v2 minus 3v3 equal to 60. Okay, now 3v1 plus 2v1 will give us what? 5v1. Thank you for following me. Then this one is minus 2v2. Do we have any minus 2v2? No, it's only this one, 2v2. And also v3, we only have 1, minus 3v3 equal to 60. And this is equation 1. Equation 1. Okay, this is equation 1. Now let's jump. We've gotten equation for v1. Now let's jump to node 2. So we also got equation for node 2 and also node 3. By all these expressions that I've made, so we can be able to do node 2. So can you do that node 2? Okay, you can pause the video and try it. Pause the video and try it. Okay, now let's do it together. What's your answer? Let's do it together. Applying KCL also at node what now? Node 2. Let's apply KCL at node 2. This is node 2. Now, I've already told you that we are going to disconnect all this, and it will now look like this. Like, I mean, you see my pen and you see this. Because you removed this one and removed this one, disconnected everything. So it will now look like T. So it will look like T. Now look at this arrow. The current flowing from here to here, that is entering the node. And don't forget, the algebraic sum of current entering a node is equal to 0. So we have I2 is entering. I2 is entering, and when it's entering is what? Positive, plus. Then let's look at Ix. Our Ix, is it entering or leaving? Is it entering the V2, the node 2, or leaving the node 2? Is leaving the node 2. Is leaving the node 2. That will be minus Ix. Now let's look at this one. Okay, this current source, is it entering or leaving? Look at the arrow very well. Look at the arrow. The arrow will determine what you are going to do. Is it entering or leaving? Is entering. That will be plus. Plus what? You know it's 4ix already. That one is fixed. 4ix equal to what? It will equal to what? 0. Thank you. It will equal to 0. It will equal to 0. Now, by using Ohm's law, you know what I mean? The Ohm's law that we use here. So by using the Ohm's law, I2 falls here. V1 minus V2. It will now be V1 minus V2 over what? What's the resistor? Over 3. Then, what next? What next? Don't forget the sign. It will now be minus. The Ix is what? Where is the Ix? The Ix falls between the V2 and the reference node, that is 0 volt. You see, is from here to here. That is Ix. So the Ix is flowing between the two nodes, this one and this one. So it will now be V2 minus 0. Because this one is 0 volts, it's nothing. It's connected to the ground. Over the resistor is what? 4 ohms, right? Now, don't forget the sign plus. We have plus here. Plus sign. Now, you know we've already have 4 here, and the Ix is here. Ix. So it will now be 4 into bracket. What's the Ix? You know we've done that one before. The Ix is what? V2 minus 0. You can write V2 only. You can write V2 only. Minus 0 plus 0 is nothing. So over 4 again. So equal to, don't forget this, 0. Thank you. Now look at this. It's very simple. Look at this. It's very simple. So what are we going to do? Let's use the LCM. Let's use the LCM. Multiply both sides by LCM of 3. You know 4 is common, and 3. So we now say 3 and 4. Okay. Now, what is the LCM for 3 and 4? What comes to your mind? I got that. That is 12. Thank you. That is 12. We now say the same way we did this. It will now be 12 V1 v2 over 3 minus v2 minus 0 over 4 plus another term 4. Should we write it like this? 4 into bracket 4 2 minus 0. Let's try something. Let's write it. 4 v2 minus 0. I just want you to learn this, so when we are doing another example, we just go straight to the point. 4. Now close the big bracket, then equal to 0. So what's next now? What's next? You know, we said this one is whole number and is over 1. Is working for all these numerators. It will now be 12 divided by 3, 12 divided by 4, 12 divided by 4. Don't forget that. Now 12 divided by 3 here, 12 divided by 3, that is what? 4. Now 4 v1 minus v2 minus, you know, this 12, this 3 has been used to divide this 12, so we don't need to write it again. Now let's come back here. 12 divided by 4, it will now be 3. 3 into bracket what? v2 minus 0 is what? v2. Now plus 4 divided by 4 is what? 1. But let's try something. 12 divided by 4, the way we are doing it before. 12 divided by 4, it will give us 3. It will now be 3 into bracket, you know, this one is 4 into bracket v2, so this one will be what? 4 times v2, so it will be 4 v2 equal to 0. Don't worry, look at it very well, you understand it. So 4 times v2 is 4 v2. You know, 12 divided by 4 is 3. You will now use that 3 to multiply this one. You know, this one has been connected together already. Now let's work here. Let's use this side. We now say this 4v1, you will now multiply it. Okay, 4v1 multiply it together. It will be 4v1 minus 4v2 minus again 3v2. I'm talking about this 4 times v1, 4v1, 4 times v2 minus 4v2 minus 3 times v2 minus 3v2 and plus 3 times 4v2. It will give us what? Thank you. It will give us plus 12v2. And you know, the way we did this, we multiplied 6 times 10. This is the LCM that we got earlier. We use it to multiply this. But if we use this 12 to multiply 0, it will give us also 0. But should I write it? No need. So 0. That will be 0. Okay, it will be 0. What are we going to do? Let's collect like terms. Collect like terms. Okay, collect like terms. You know, we only have, how many v1 we have here? Is only 4v1. 4v1. It's only 4v1 that we have. Now it's only 4v1 that we have. We have minus 4v2. Pay more attention. Minus 4v2 minus 3v2. It will give us what? Minus 7v2. Let's do it like that. You know, we still have v2 here, so let's do the minus first. Then another one, we have plus 12v2 equal to 0. Now 4v1 You know we have minus here and we have plus here. So minus 7v2 plus 12v2. That is when we deduct this 7 from 12, it will give us what? Think. Don't use your calculator, just think. It's 5. Thank you. Plus 5v2 equal to 0. 0. Now this one is equation 2. Thank you. Equation 2. Equation 2. This one is equation 2. Now let's move on to node 3. Node 3. Node 3. Node 3. Node 3. This one is node 2. And this one is node 1. Node 1. Okay, node 1, node 2, node 3. Now you know how we are doing it? We will apply KCL, then Ohm's law. Okay, just follow the rule. It's very simple. Applying. Just pause the video and do it. What do you get? Okay, let's do it together. Applying KCL. If I say you should pause the video, just pause the video and try it, whether you get it or not. So we will now do it together. So at node 3. Now let's come back to the node. So this is node 3. This is node 3 here. Node 3. We've done this, and this is the remaining one we are going to do now. This is node 3. Okay, now this node 3, look at it. We are going to disconnect this one. Now it will now remain this wire, this wire, making 3, right? Now, so let's look at it. You know this wire is also connected to this, so you are going to use it. Don't forget, the algebraic sum of current entering the node is equal to 0. That is Kirchhoff current law. Okay, Kirchhoff current law. It will now be okay, I1. You know I1 is flowing here, the current is flowing here and is entering the node. I1 is positive, you know that. Now let's look at this one again. 4ix, is it entering the node or leaving the node? Is it leaving the node 3 or entering the node 3? It's leaving, and when it's leaving is what? Minus 4ix. Thank you. Now let's move on to I3. This I3, is it leaving the node or entering the node? It's leaving. Look at the arrow, it's leaving. It will be minus I3 equal to 0. Don't forget, algebraic sum of current entering the node is equal to 0. Now, the way we are doing it before, this I1 is flowing between which node? Let's look at it. I1, this is I1, is flowing between this V1 and V3. So it will now be applying Ohm's law. It will now be V1 minus V3 over what? The resistor between them is what? 2. Thank you. Don't forget the sign, minus this 4ix. This 4ix. You know, we've already gotten ix already. This is our ix, the current flowing here. You will use it. 4 into bracket. The ix is what? V2. You know V2 minus 0 volt. That is reference node. V2 minus 0. Just put it. So, and the resistor between it is what? 4 ohms. 4. Now minus. Now let's come to I3. The I3 here is the current is flowing between what node and node? This node 3 and this reference node. Now it will now be V3 minus 0 over what? The resistor between them is 6. Okay, equal to equal to 0. Don't forget. When we are doing one example, you will understand it, but this one is very straightforward. V1 minus V3 over 2 minus 4 V2 minus 0 over 4 minus V3 minus 0 over 6 equal to 0. That's why I say you should pay more attention following this and take your pen and your book so we can work it together. Now let's try something. So V1 minus V3 over 2. So what are we going to do now? Let's use the LCM. You know, the LCM here. What's the LCM? Think about the LCM that we can use. The LCM that we can use, that 2 can go in it, 4 can go in it, 6 can go in it. Think about it. What comes to your mind? You say 12. Good. You now say multiply both sides by LCM of 2, 4, and 6. Thank you. 2, 4, and 6. And the LCM is what? 12. Thank you. We now say 12 into bracket V1 minus V3 over 2. Okay? Minus 4V2. Let's multiply it straight. 4V2 over 4 minus V3. This V3 minus 0 is V3 also. So over 6. No need of writing it. Now when you use that 12 to multiply 0, you know it will give you 0. To give you 0. Now, what are you going to do now? 12 divided by this 2 is what? It will give us what? 6. 6 into bracket V1 minus V3. Close the bracket. Don't forget the sign minus here. Now 12 divided by this 4. It will give us what? 12 divided by 4. It will give you what? 3. Thank you. 3 into bracket 4V2. Then minus, don't forget the sign here. Now 12 divided by 6 will give you what? 2. 2 into bracket V3 equal to 0. Now let's multiply it. 6 times V1, 6V1 minus 6V3 minus 3 times 4V2, 12V2. Okay? Minus 2 times V3 minus 2 times V3 give us 2V3 equal to 0. What are we going to do here? Let's collect the like terms. Collect like terms. Okay? Collect like terms. Now, what's common there? We have 6V1 minus 12. Is it 12? Yes, minus 12V2. What again? We have 6V3 minus 2V3. That would be minus 8V3. You know it's minus minus. So you are going to add it together. Minus 6 minus 2. It will give us minus 8V3 equal to 0. Okay? Equal to 0. I think that will give you, this is equation 3. Wow. Equation 3. We've gotten equation 1, equation 2, equation 3. Now how are we going to use this equation to get V1, V2, and V3? Thank you. Now, don't quit yet. We are still going. Now, before we can get that, let's use Crammer's rule. Crammer's rule method. Crammer's rule method. So to get V1, V2, and V3. Okay, to get V1, V2, and V3. let's write out the equations. So we can use the Crammer's rule. The equation 1 here we have v 5v1 minus 2v2 then minus 3v3 equal to 60. Remember. Then another one here we have 4v1 plus 5v2 equal to 0. That is equation 2. Then equation 3 we have 6v1 minus 12v2 minus 8v3 equal to 0. Okay, now we've gotten our equations, equation 1, 2, 3. Let's try something. When we have some complete, some have v1, v2, v3, v1, v2, v3, but like this equation 2 now, it has no v3. Now bear this in mind, that anywhere that you don't have anything, that is, if something is missing and you don't have it, is 0. What's next? What are we going to do next? So we are going to determine the v1, v2 and v3. So that's what we are going to do now. We are going to determine the v1, v2 and the v3. Let's rewrite this for better understanding. We are going to rewrite it. I've told you that this one is v1, v2, v3 is complete, v1, v2, v3 is complete, but this one is not complete, that is, it's nothing. So we are going to use 0 to replace the v3 just to balance the equation, and if you don't put it, it's nothing. But let me put it. So 5v1 minus 2v2 minus 3v3 equal to 60. Then 4v1 plus 5v2 plus or minus, you can use plus or minus for 0, it is still the same thing, 0 equal to 0. Now another one, 6v1 minus 12v2 minus 8v3 equal to 0 also. By using the Crammer's rule, v1, v2 and v3. But before we can get the v1, v2, v3, we have to get the determinants. Okay, we have to get the determinants. We have something like this: v1 equal to determinant 1 over determinant, v2 equal to determinant 2 over determinant, v3 equal to determinant 3 over determinant. So these are the formula we are going to use. But listen, before we can get the determinant, let's try something. So we have to get the determinant first. Please pay more attention. Please, I'm begging you, pay more attention. Don't let anybody disturb you. Don't let anything distract you. Determinant equal to 5. You are going to remove all these v1, v2, v3. You are going to remove everything. 5. What's next? 5, 4. I'm doing this column. 4, 6. Then another column now. 2. That one is minus. Don't forget to put the minus. 5. I may put plus 5 or just ordinary 5. We already know that 5, since it has no sign, is positive. Okay. Then don't forget the negative sign. It's very, very crucial. Very, very crucial. And then another column. I mean this column. 3. This column minus 3. Then let's put the 0 minus 8. Okay. Now please pay more attention to this. I'm going to repeat the first two rows. This formula, I'm going to repeat the first two rows. I mean this row, I'm going to repeat it. I'm going to write it here. Look at it. 5 minus 2 minus 3, and another one 4, 5, then 0. You see that? Then 0. What am I going to do? You will now use arrow. This arrow will start from this edge, this 5, touch this one, touch this one. Okay, this arrow goes this way, then another one, you see the arrow, it touched this 5, 8, 4, 12, 3, 6, 2, 0. Then another arrow will start from this edge again, go, go, go. Don't bend your hand, don't curve it. Just once you take this edge, just go like that. It must touch the 3. Then another one. You see, now it will remain this. Just leave them. We have nothing to do with that because it's here already. Okay, so this side will be plus, plus, plus. This side will be negative, negative, negative. Reason we are putting this plus, plus, plus here is that anything that we get here, we are going to multiply with this sign, and anything that we get here, we are going to multiply with this sign. Okay, so 5, I will have write everything out like 5 times 5 times minus 8, but it will be too bulky. I don't want you to get bored. You can, when you are doing your exam or your test, you can try that. Just write everything out full, so you get your full mark. But I don't want you to get bored here, so let's try to make something fun. Okay, so 5 times, I'm going to multiply this 5 times 5 times minus 8. This is where the knowledge of minus times minus equal to plus, plus times minus equal to minus, minus times plus equal to minus, plus times plus equal to plus. This is where the knowledge, you are going to use the knowledge, is very useful. The knowledge is very useful here. Please pay more attention, don't make mistakes, and don't forget all the signs. If you miss the signs or you forget to put the sign, everything will just mess up. Okay, so and we don't want to mess here. So 5 times 5, bring out your calculator and let's try this. As I'm pressing my calculator, you to press your calculator. Press your calculator. So 5 times 5 times minus 8 equal to what? Minus 200. That minus 200, you will now multiply it with this sign, this positive. It will now be minus 200 times plus is also what? Minus 200. Minus 200. You know, minus times plus is minus. Then we now come to another arrow. This is another arrow here. This arrow, 4 times minus 12. Let's try that. 4 times minus 12, then times minus 3 times minus 3. That will give me 144 times plus. It will give me plus 144. Okay, then look at this one, the next arrow, that is the third one. The next arrow, this is 6 times minus 2. It will give me what? Minus 12. Okay, don't doubt, not everything you'll be using your calculator, but let's try that. 6 times minus 2 equal to minus 12. I told you. Then times this 0 times this 0, it will give me 0. So times this plus, I don't need to write it out. I can write it, or I can put sign, is it maybe negative or positive, anyhow. So plus 0. Then another one, let's come to this arrow again. This one, we've done this one, we are going to do this one. So minus 3 times 5, that will give me minus 15. Minus 3 times 5, minus 15 times 6, I think that one is on 90, I think so, times 6, yes, 90. It gives me minus 90. You can see that, minus 90. You now use that to multiply like we did here. You are going to use minus 90 to multiply this sign. So minus 90 times this minus, it will give us what? Plus 90. Thank you. Plus 90. Plus 90. Then another one, there is 0 here already. So and when we multiplied everything, it will give us 0. Is it that you write minus 0 or plus 0? I mean this. 0 times minus 12, 0 times 5, 0 times this, 0. Let's use minus 0 so to indicate it. It's nothing, but let's put it there. Now we have minus 8 times minus 2. Minus 8 times minus 2, that's what? That will give us plus 16. Now, don't doubt. Let's try that. It's not everything you'll be using your calculator. Some simple. You see, 16 times this 4 times 4. It gives me what? 64. Now that 64 times this minus. That 64 is positive already. 64 times minus. It will now give me minus 64. Minus 64. Now let's check the algebraic sum of this to get my determinant. Now. My determinant, let's add it up. Minus 200 plus 144 plus 0 plus 90 minus 0 minus 64. It gives me what? Minus 30. Minus 30. Minus 30. That is my determinant. Determinant. Wow. So we've gotten our determinants now. What else? What are we going to find? Let's find our determinant 1. Let's go get our determinant 1 now. So our determinant 1 here, So our determinant 1, how are we going to do our determinant 1? This one is V1. This one is V1. So this one is determinant 1. So let's come back to this. We have V1 here. So we are going to remove this one and replace it with this. We have 5V1 here, 4V1, 6V1. I'm talking about this column. So you are going to remove everything here and replace it with this 60 and 0, 0. So let's try that. Using this same method, you have something like this. 60, you have 0, you have 0. Then you now use this one, minus 2, then this 5, and then minus 12. Then another thing, you are going to write this one here. So it will now be minus 3, 0, then minus 8. Okay, minus 8. Now, like we did here earlier before, we said the first 3 rows, the first 2 rows, I mean this one, we are going to rewrite it here. So same thing applies to this also. The first two rows, we are going to rewrite it here. It's very simple. So 60 minus 2 minus 3, 0, 5, 0. I love this one because 0 is much. I will not calculate much. So let's try that. Let's get our determinant 1 equal to. So before we go that, let's try the arrow that we did earlier. Got it. Then another one comes this way, another one comes this way, then another one go this way, don't mind my line, this way. So this one is, remember, is what? Positive, 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 negative, negative, negative. Okay, so let's try this. This one, 60 times 5. Let's try that. 60 times 5 times minus 8. It gives me minus 2,400. Minus 2,400 times this plus. You know, I'm talking about this arrow. It will give me what? Minus 2,400. I don't need to multiply that. Minus 2,400. Then another one, we have 0 here. So that means everything is what? 0. Don't stress yourself. Since this one is 0, minus 12 minus 3 is 0. So you now, is either you put plus 0 or minus 0. Anyhow, plus 0. I just want to put it there, so when we are calculating it, we get your answer. Then another one, we have 0 times minus 2 times 0 is what? 0. 0. So it's now 3. 1, 2, 3. Now let's try this one again. So minus 3, 5, everything is 0. Everything is 0. This one also is what? 0, 0. This one also is what? 0. Oh, wow. So we have our determinant 1 equal to minus 2,400. Okay, so this is my determinant 1. My determinant 1. Let me use this determinant 1 to get my V1 straight up. No stress. Let me use to get my V1 straight up. So my V1, you know, remember this formula we said we are going to use. We are going to use V1 equal to determinant 1 over determinant. So it will now be V1 determinant 1 over determinant. So I just write it here so we can remember. So it will now be V1 equal to minus, don't forget the sign, minus 2,400 over, the determinant is what? Minus 30. So V1 will now equal to what? It's still on my calculator. So divided by minus 30, that's 80 volts. Don't forget the units. If you don't put the units, all what you have been doing this morning is 0. Trust me, is 0. So you have to put the unit no matter how. Now this is V1 equal to 80 volts. Now let's get V2. To get V2, you know how we are going to do it. We are going to get the determinant 2. Determinant 2 equal to same method. Now, you know V2, you are going to replace V2 with this 6000. Okay, you remove everything here and place this one here. It will now be 5, 4, 6. Then you now put this 6000 here. 60. Don't follow the sign because we've removed everything. 60, 0, 0. Then another one here. Just write this one like this. Minus 3, don't forget the sign, minus 3, 0, minus 8. Okay, so we are going to repeat the first 3 rows. I mean this row, the first 2 rows, sorry, the first 2 rows. So it will now be 5, 60 minus 3, then another one, 4, 0, 0. Okay, it's now complete. You now draw the line. You know how we used to draw the line. This, and this. You know, it's now complete. Now let's take from this edge now. From this edge, this, and this. You see, you will now put the sign. It will now be plus, plus, plus. Then this one will now be negative, negative, negative. That is minus, minus, minus. I love this one also because there are plenty 0 here. Now this one we have 5, 0, 8. So we are going to multiply everything. 5 times 0 is 0, 0 times minus 8 is 0. So our determinant 2 now will now equal to 0. So we've done this line. Another line, 0 also, 0. Another line, 0 also. Then this one, it will give us, this one also will be 0. What of this? 0. What of this one? This one will not give us 0. Look at it very well. So we have minus 8 times 60 times 4. So minus 8 times 60 times 4. It will now give us what? Minus 1920 times this minus. It will now give us plus. Don't forget that. It will give us plus 1920. It will give us plus 1920. So our determinant 2 here is 1920. You will now, if you want to get the V2, what are we going to do? Don't forget the formula. The formula is here. V2 equal to determinant 2 over determinant. So V2 equal to determinant 2 over determinant. I'm just writing it so you can remember. So you now say V2 equal to determinant 2 is what? 1920 over our determinant. What's our determinant? Minus 30. So let's try that. It's still on my calculator. Divided by 1920 divided by 30. No, 1920 divided by minus 30. It will give me minus 64. So minus, my V2 is minus 64 here. Minus 64. Minus 64. Minus 64 volts. I already told you that if you don't put the units, all what we've been doing since morning is 0. So then let's get our determinant 3 now. Our V3. We've gotten our V1, our V2. Then let's get our V3. So our determinant 3 now. Determinant 3. So our determinant 3 now equal to, we are dealing with determinant 3. Definitely we are going to remove all this column for V3. So we are going to replace it with this 6000. Okay, so it will now be 5, 4, 6. Then this one, the 2, minus 2, 5, minus 12. What of this? We said earlier that we are going to replace it with this. So 60, 0, 0. What next? Tell me. Okay, so we are going to replace rewrite this first two rows, sorry, first two rows, that is 5 minus 2 60, then 4 5 0. Now let's draw the line how we normally do it. So 5 here, 5 5 0, and 4 minus 12 60, 2, that's 6 minus, now this side will be plus 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 plus. Okay, then another one, we have this and this. So this side will be negative negative negative, that is minus minus minus. And this one also is very straightforward because there are a lot of zero there, but let's try it. So we have 5 5, that is 5 times 5 times 0 will give us 0. 4 times minus 12 and times 60. Let's try that. 4 times minus 12 times 60, that's minus 2,880 times this plus, it will now give me minus, minus times plus, don't forget minus times plus is what? Is minus 2,880. okay, minus 2,880. Then another one, this one will give me 0, so 0 0 0 0 plus 0, so it now 3, 1 2 3, 1 2 3. Then another one, 60 times 5 times 6. Let's try that. 60 times 5 times 6, that is 1,800. We have negative sign here, we are going to multiply with the negative sign, that is minus, we got 1,800. When you multiply with this minus, it will give you minus negative 1,800. Then what else? This one, we have 0 here, so when you multiply everything, it will still give you 0 minus 0. And this one also, we have 0 here, when you multiply everything, it will still give you 0. Now let's add everything up. We have 0 here, so neglect the 0, you don't need it. Minus 2,880, then minus 1,800. It will give us minus 4,680, that is minus 4,680. You see that, minus 4,680. That is our determinant 3. But let's find our V3 now. That's our determinant 3. Let's find our V3. Okay, our V3 equal to determinant 3 over determinant. So V3 now equal to this, our determinant 3 is what? We just got that one now, minus 4, don't forget the sign, minus 4,680 over, then what's our determinant? The determinant we've been using since, that is 30, minus 30, minus 30. So V3 equal to what? I still got out on my calculator, minus 4,680 divided by minus 30 equal to 156. So 156 volts. Don't forget the unit. I keep telling you, if you don't put the units, all what you've been doing since morning is 0. So we've gotten our V3. Our V3 is 156 volts. So you can try something. You can try to check, or you will redraw the circuit. After redrawing the circuit, you can now place everything inside. You will do that one, but I will teach you how to check whether you got your answer correctly in the next video. But let's try something out. Our answer here, you will now rewrite it. Our V1 is what? This one is called summary. Let's summarize everything. Our V1 is what? 80 volts. Our V2 is what? V2 is minus 64 volts. Then our V3 is what? 156 volts. Bear that in mind. This is all the voltage that we need in the circuit. Now let's try something inside the circuit. Let's try something inside the circuit, the one that we've done earlier. So we are going to include, okay, I've seen it, this place. Now what are we going to write there? Let's write the voltage that we got here. So that is when you analyze your circuit. Okay, let's redraw it. When we redraw it, we now put it inside. Sometimes it's not necessary, but when you are doing your exam, you have to do that. You have to redraw your circuit. So it's something simple. So let's try to redraw our circuit here. Okay, this, we have this, a quick one. We have this, then this one comes this way. We have a source here. Again we have this 10 ampere. Let me label it straight up. 10 ampere, 4 ohms, 6, oh sorry, there's a resistor here, 6 ohms, 3 ohms, 4 ix, 2 ohms, node, and this one is reference node. You already know reference node is 0 volts. You now write what you got here. That is your V1 is what? Your V1 equal to what? 80 volts, right? Then your V2 is what? Your V2 is let's check that. Your V2 is minus 164, minus 64 rather. Then your V3 is 156 volts. So this one, just analyze your circuit. Sometimes if you want to get the answer, like you've gotten 80 volts, minus 64 volts, and 156 volts, if you want to check your answer, maybe you are correct or you are wrong. So we are going to use these node voltages to determine the currents that flows here already. You know, we said this one in the IX, I2, I1, and something like that. But after finishing your exam, you have to include this circuit. You have to redraw it and analyze it like this. So that is what we call circuit analysis. This is theory part, and then practical. So when you are given circuit like this, or you want to build something, you have to calculate the voltage that drop across each node, so to determine the current that's flowing inside the circuit. Okay, so thanks for your time. More video will be done on voltage, nodal analysis. More video will be done on that. Then the next one will be Thevenin and Norton's theorem, then the AC circuit analysis. Thanks very much for your time. The next will be dropped soon. Please subscribe and share. Thank you.